So we know that it's going to take 5 hours or less for option B to be less expensive. Now, let's kind of go a little bit further and let's see how to actually solve this inequality using the things that we've built and not kind of relying on just kind of modeling out a table here. This is great to kind of frame our thinking, and we get our answer in the end that it's going to have to take 5 hours or less to do it. However, let's go back and let's actually use our inequality of 40 plus 8t is greater than 15t. And let's actually figure out how many hours it would take on the spot or on the, like by decimal, or exactly how many hours it would take for option A to still be greater than option B. So what we're going to do is we're actually going to go ahead and we're going to solve this question. It might be interesting to kind of solve it the reverse way as well, but we'll start with this one and we'll see if we get down to something that we already have kind of proven just by working with the numbers and working with the patterns. Let's go ahead and let's isolate for t. Now, in this case, I see that I have a 40 on this side, and I have a term with t on this side, as well as a term with t on this side. Well, I don't like to have all of my t's separated on this, so I'm going to actually end up subtracting 8x from both sides. And I'm going to isolate my t term. Normally, I like to have my t term or my unknown term on the left-hand side. It just kind of looks like that's not going to be available for me to use right now. So I'm going to have to use it on this side, and maybe I'll kind of take a look at my answer afterwards and try to change it up from there. I'm going to go ahead and now divide both sides by 7. Divide by 7. Now I'm going to need a calculator for this one, so I'm going to go ahead and take 40, and I'm going to divide it by 7, and I'll get that it's going to take 5.7, it looks like, and I'll go for 3 decimal places, 5.714 hours is greater than t. So this is kind of awkward to say. I'm going to rewrite this in a different way. T has to be less than 5.71 hours for option B. Option B to be less money than option A. So this would be kind of if the question was asking for, if the question kind of went with, okay, you can have decimal answers or you're not going to deal with whole numbers. I kind of wrote this question and I just kind of said, well, usually people would charge on a per hour basis and they would just use for how many hours it would be. Kind of depending on what this company would, I could see them either rounding up or just saying the full hours of 5 hours would be that case. It's kind of up to a little bit of interpretation for this one. But we would know exactly 5.71 hours for option B to be less expensive than option A. There is a different way for us to take a look at this question. This kind of coincides with the work that we did over here, and we know that if it's 5 hours or less to be less expensive in choosing option B, that still works with us because we chose the nearest whole number and we didn't round up. So this still works with our whole number approach. If we wanted to, we can certainly kind of assume the different. We can assume that, okay, when would option A be a good idea? So that could be an option for us to kind of think about as an extension to this question. When would someone take option A? When would somebody take option A? So this is really kind of the reverse of what's going on here, where when would this actually become more cost effective than option A? And we could look at it as the inequality actually looking at the different. We could look at it saying that option B, or assuming option B would be more money than option A. So we can look at this and we can do this question again, but if we already have the answer for where option B is going to be less than money than option A, then we can just kind of say if T were greater than 5.71 hours, then option A would be more cost effective, or you could say just less money than option B. Then option A would be better. So we don't actually have to go through a list of values, of whole number values. We don't have to go and analyze that. We could take our exact answer from before and just say, all right, if the time is going to be larger than what we've mathematically proven over here, then it would just be the opposite case. I guess I should say here, if we're assuming whole number answers, and again, this was a little bit up to interpretation. If we want only whole numbers, we would say that t would have to be greater than 6 hours here, just to kind of coincide with what our option would be from before. It wouldn't make sense to say it would have to be larger than 5 hours, because if it was 5 hours, and again, we can only go in whole numbers, then technically 5 hours, it would actually still be option B. That would be cheaper. But if we're going for full numbers, or whole numbers rather, then we would just say t is greater than or equal to 6 hours. And that would give us our absolute minimum case of 6 hours, where option A would be just slightly cheaper than option B. And then anything over that would be, of course, cheaper than option B as well. So difficult question, a lot of different ways to frame your thinking. I would encourage you to at least get to something like an equation for both of these ones. If you have to use a table for that, that's all right. We sort of assumed whole numbers when we were doing this, or at least I assumed whole numbers when we were doing this question. And we kind of found that at the whole number of 5, that was the last, or the 5th hour, that was the last full number, that option B was less expensive than option A. And then we kind of mathematically proved that by using our inequality. And if we were going for, the exact time, then 5.714, I just chose to be 3 decimal places. And that would be the exact time that you would have to be less than for option B to be less than option A. And then as an extension, I just kind of made it up by myself. But if we were to take option A, then you would have to be greater than that time. And if we're looking at whole numbers, then it would have to be at least 6 or greater. And that should really cap off the unit. Spend some time doing some practice on this, especially one of these like 2-part questions, because those are really, really good at really framing your thinking for these.